Okay, this is a question on the line of symmetry. Okay, so to do the question on line of symmetry, right, it's very easy. You just place this is a line of symmetry. Okay, so you place a ruler that forms a T shape with the line of symmetry. Can you see? A T. Okay, so and you slowly slide down the ruler along the line of symmetry, still maintaining the T shape. So this is how it's going to be. So can you see that as you slide down, right? On this side, you see a corner. Okay, the corner of the triangle. Okay, and by right on the other side, it should also touch the corner of the triangle. Okay, but you see that the corner of the triangle is not at this point, but it is this point. Okay, so there is a mismatch. So this is not the line of symmetry. Okay, so we do not put a tick. And another way that you can see the line of symmetry, right, is that if you fold this figure along this line of symmetry, they should match perfectly. But if you were to fold it along this line, you find that it does not match. Okay, so this is not a line of symmetry. Okay, whereas if you look at this star, right, same thing, this is the line of symmetry. Take a ruler, form a T. Okay, so as you slide down, can you see that this is a corner? Okay, it will also touch the other corner. Okay, so as you slide down, there's another corner here. It also touch the corner that bend inwards. Okay, as you slide down, okay, this corner matches with this corner, and as you slide down, it matches perfectly all the corner. So this is a line of symmetry. So this is a symmetrical figure. If you were to fold along this line, right, okay, the left and the right side of the star will match perfectly. So this is a line of symmetry. We put a tick. Okay, is that clear? Let's move on for B. Okay, so we need to complete the figure with XY as the line of symmetry. Okay, so what we need to do, right, same thing, we take the ruler, form a T shape with the line of symmetry, and we slowly move it down. Okay, so as you move to this column, right, you find that there is a shaded square on top. So there must be a shaded square at the bottom. Okay, so that it match. So one on top, one at the bottom. So I shade. As you go to the next column, you find that there is a half a square and a full square. So as you move down, this should be a full square. Okay, then after that I need to draw half a square, right? So half a square, do I draw it this way or this way? Okay, you look at how it's supposed to be like in the given figure. It goes from top to bottom. Okay, so we are drawing a mirror image, so it has to be from the bottom to the top. So it goes like this. Okay, so if you were to fold along this line, they matches perfectly, right? So we move on to the next column. Okay, half and a full square. So this will be a full square. Okay, then the half, it goes from the bottom to the top. Okay, so from here, it will be from the top to the bottom. Okay, mirror image. Okay, then the next column is 2 on top, so I need 2 below, right? And the next one, from top to bottom, then I have a full square. So I draw the full square first, then from the bottom to the top. And lastly, I have 1 square on top, so 1 square below. Okay, so with this, I think we are done. Okay, if you were to fold the whole figure along this line of symmetry, they should match perfectly, right? Okay, Samantha has half kg of berries at first, and 1/5 kg of the berries were rotten, and she needs 2 kg of berry to bake a cake. So how many more kg of berries did Samantha need to buy? So guys, I'll represent this question with a model. So half a kg is what she had at first. So we just need to draw this. Okay, then we can just put a bracket. This whole thing is half a kg. And 1/5 kg of the berries were rotten, right? So we have to take it away. So this part, is what we will take it away. It is 1/5 kg. Okay guys, at this point of time, right, maybe we can find out how much berry does Samantha have left. So we will just take half, sorry, this is 1/5. We will take half minus away 1/5. Okay, so minus 1/5. Okay, to minus fraction, we change the denominator to the same number. So it becomes, this will be times 5, this will be times 2. So I have 5/10 minus 2/10. So she had 3/10 kg left from here. 3/10 kg. Okay, so now the problem is that she needs 2 kg. That means she needs this much. 2 kg to bake a cake. So she already has this 3/10 kg left, right? So she needs all together 2 kg. So what is this extra amount that she needs to buy? Okay, what we can do is just take 2 minus 3/10. Okay guys, this is the part that students might have a bit of problem, because this is a whole number. How do you take a whole number to minus off a fraction? So we borrow 1, okay? So this 2, I borrow 1 whole, so I'm left with 1 whole, and the other 1 whole I change it to a fraction. So the fraction, it will be 10/10. Okay guys, why do I change it to 10/10? Because I need to minus this fraction 3/10. So I change it to the same denominator, so it's easier to minus. So at the end, I will get 1. And 10/10 minus 3/10, take note, only minus the numerator. That will give us 1/7/10 kg. Okay, that's the answer. Okay, question 39. Ethan wants to pack 36 pencils and 27 rulers into a goodie bags. So each item is packed equally into the goodie bags. So what is the greatest number of goodie bags that Ethan can pack? Okay guys, when we talk about this greatest number, so please take note of this keyword. When you see the greatest number, okay, or the smallest number, usually we are dealing with highest common factor or lowest common multiple. Okay, but because this is the greatest here, right? Can you see? So it has to be usually the HCF, which is the highest common factor. Okay, so if you look at the question, Ethan has 36 pencils and 27 rulers. He's supposed to pack them into goodie bags. Okay, so both of the two numbers must be able to be divided by the same number, okay, which is the number of goodie bag. So if you want the greatest number of goodie bag, right, what you can do, I say this is a highest common factor question. You list out the factors of 36 and 27, okay, and this is how I'm going to do it. So this is 36. How I list out the factor, it will be 1 times 36 equals 36. 2 times 18 equals 36. 3 times 12. 4 times 9. And 6 times 6. Okay guys, when do you stop when do you stop with the multiplication to find the factors, right? When the number on the left side, okay, reaches the number on the right side. That means you go down in sequence, right? 1 2 3 4 6. Then after that, you see, you touch the number on the right side already. So when you reach the number on the right side, you can stop. That means you won't miss out any factors, right? Let me try with 27. So same thing, 1 times 27 equals to 27. And please take note, if this is an odd number, you can skip all the even factors here. That means 2, 4, 6 you can skip, because even number, no matter what number you times by, it will never give you an odd number. Okay, so you can skip 2. The next one is 3. Okay, can 3 times 9 can get 27. 4 we can skip 5. 5 times, you cannot times 5 by any number to get 27, so you can skip. So 7 is the same thing, you can't get 27. Then the next one will be 9. So 9, you reach this number on the right already, right? Means there is no more factors. Okay, so looking at the factors of 36 and 27, right? Which is the highest common factor? So you look at the factor that is the same and that is the largest. Okay, so maybe we look at 27, no 27. How about 9? Yes, there's a 9 here, there's a 9 here. So the highest common factor is 9, and the greatest number of goodie bag that Ethan can pack, it will be 9 goodie bags. So that means, right, I'll just push the question a little bit forward. If you look at 9, right, there's a 4 here. So it means that in every goodie bag, you will put in 4 pencils each. And in every goodie bag, he will put in 3 rulers each. Okay, so this is a question on highest common factor. Okay. Adeline had 3 times as many marbles as Betty. After Adeline had given Betty 25 marbles, they had the same number of marbles each. So how many marbles do they have all together? Okay guys, this question is actually quite straightforward. What you need to do, right, is that we have to do a before after. Okay, the reason is because, right, there is a change to the number of Adeline and Betty. Okay, so when there is a change, we have to draw before after to represent the change. Okay, so this is like a 2-step question. So first of all, Adeline, okay, and Betty. Adeline had 3 times. 3 times means that Adeline would be 3 units and Betty would be 1 unit. Okay, so let's draw it. So Adeline, I will draw it this way. 3 units and Betty would be 1 unit. Okay, next, after Adeline gave Betty 25 marbles, they had the same number of marbles left. Okay, they have the same number of marble each. Sorry. So guys, can you please take note, this is the type of question, right? Is when A gives to B. Guys, whenever let's say there's two person in this group, right? And if there's only a movement between from A to B or from B to A, there is something that will stay constant. Okay, the total will remain constant. Okay, because you see, if A gives to B, right, A will have lesser, B will have more, but the total will still be the same because the total number of marbles will still be between A and B, right? So in this case, if Adeline had given Betty 25 marbles, right, the total would be the same. So this is the total. Okay, and when we draw the after model, right, this is A, this is B. Can you see that before the total is 4 units? Am I right? So after the total, it has to be the same. You should also see the same 4 units. And it says that they had the same number of marbles each after Adeline gave Betty, right? So 4 units divide equally by 2. Each one will be having 2 units each. So let me just draw it this way. Okay, so this is how it's going to look like. Can you see it's 4 units at the beginning and 4 units at the end? Because A gives to B, the total doesn't change. Okay, and now let's try to put in the numbers that we have. If Adeline had given Betty 25 marbles, right? Okay, so can you see that Adeline from before to after, right? Adeline actually gave Betty 1 unit. So this 1 unit that is given is actually 25. Okay, so how many marbles do they have all together? So the question becomes easy now. So 1 unit is 25 So altogether there are 4 units. So 4 units will be 4 times 25. That will give us 100. Okay, that's the answer. Okay, question 41. Annie and Sarah had the same number of stickers at first. So guys, same number, please take note. Okay, so when we draw the model, right, they should have the same unit. Okay, so this is exactly the same before after question again. So maybe I just represent the first line first. So before, this is Annie and this is Sarah. So they have the same number of sticker. Okay, so after Annie had bought 38 stickers and Sarah had lost 25 stickers, Annie had 4 times as many stickers as Sarah. Okay, so how many stickers did each girl have at first? Okay, so now let me just draw the after first. Okay guys, if you look at this, Annie had bought 38 stickers. If Annie bought 38 stickers, right, Annie should be longer. Am I right? So this Annie, okay, if you were to draw it, it has to be longer than before. So how long? I'm not too sure, but I just draw it slightly longer like this. Okay? And Sarah had lost 25 stickers. So Sarah, I just cut it shorter because she lost 25. So this is Sarah. Okay, so maybe something like this. Okay. And now, Annie had 4 times as many. Annie had 4 times as many stickers as Sarah. So that means at the end, right, Annie would have 4 units and Sarah will have 1 unit. So this is how I'm going to draw. This is 1 unit, right? So Annie, I'm going to draw 4 units. 1, 2, 3, 4. Okay? So now I'm going to put in this 38 and this 25. Guys, this 38, right, is what Annie bought. So Annie before is this, Annie after is this, because there is an increase of how many? There's an increase of 38. Okay, and for Sarah, right, Sarah dropped from here to here. So because Sarah lost 25, okay, so this has to be 25. Okay guys, do you all see something here? Okay, basically after we draw the model, right, we have to try to pack a number to the number of units. Okay, so can you see that this 3 units, okay, you can actually find how much is this 3 unit, 1, 2, 3, because can you see this? This is 38 up to this point, then after that I have another 25, then it comes here. So this entire 3 units, right, it will be 25 plus 38, and that's how we can solve the question. Okay, so 3 units will give you 25 plus 38. That will be 63. So guys, whenever we find 3 units, the next step it will be to go on and find 1 unit. So 1 unit will be 63 divided by 3. That will give us 21. Okay, so how many stickers did each girl have at first? Guys, each girl have at first, can you see that it's actually 1 unit? We are finding this, right? So how to find this? It's actually 1 unit and plus back 25. Do you see it? Okay, so the answer, it will be just 21, because this is 21 plus 25. That will be 46. That's the answer. Okay, question 42. A farmer had 4 times as many apples as oranges. Okay, so after he had sold 175 apples, right, he had twice as many oranges as apples. So how many apples did he have left? So guys, can you see that there is a change in the number of apples. So when there is a change in the number of apples, we have to draw the before and after model. So before, right, of course we will draw apple and orange. So can you see this? 4 times as many apples as oranges. So apples would be how many units? 4 units. Okay, 4 times. And this orange would be 1 unit. Okay, so that's how we are going to draw. So apple 1, 2, 3, 4. And orange would be 1 unit. Okay guys, I want you to see something here. As we draw the after, right? As we draw the after, he sold 175 apples. So the apples is going to decrease. But did he sell any oranges? No. So the number of oranges will still remain the same. So because of this, okay, we can draw the orange first. So the orange still stays the same. Okay, it is like this. Okay, then he had twice as many oranges as apple at the end. Can you see? Twice as many oranges as apples. So that means now the orange is how many units? It has to be 2 units. So how do I change this to 2 units? I just need to cut this into 2. And the orange is 2 units and the apple would become 1 unit. So this is the apple. Apple becomes 1 unit like this. Okay. So guys, now the next thing that we need to do, right, is to try to divide all the units into equal size. Can you see that the before unit is bigger than the after unit? But each before unit, right, can you see, can be cut into 2 equal half, and that will be the same size as the after. Okay, so that's what we are going to do. So cut this into half. Can you see that the unit size for before after they are the same now? Okay, so now we are ready to do the comparison. He sold 175 apples, right? So if you were to draw this down, so this apple from how many units? 1, 2, 3, 4, 5, 6, 7, 8 dropped to 1 unit. So that means this decrease is actually the number of apples that he sold. So this will be 175. Then you count the number of units. 1, 2, 3, 4, 5, 6, 7. 7 units gives you 175. Am I right? So 1 unit will give 175 divided by 7. I will get 25. Okay, so how many apples did he have at first? So can you see that the apple? 1, 2, 3, 4, 5, 6, 7, 8. 8 units of apple at first. So it will be 8 units will give you 25 times 8. The answer would be 200. Okay, question 43, right? This is quite a difficult question at this point of time. So please try to pay attention to my explanation. Belinda had thrice as many sweets as Wan Li at first. Okay, so please take note of the thrice. So thrice means that Belinda would have 3 units. Okay, and Wan Li would have 1 unit. And can you see that Wan Li will give away 8 sweets? Okay, so guys, maybe we hold first. We draw the before model first. Okay, so Belinda has 3 units. Okay, so 1, 2, 3, and Wan Li has 1 unit. Okay, so after Wan Li had given away 8 sweets, so we know that after, right, Wan Li would have lesser. So I draw Wan Li. Okay, this will be probably her what she has left. It's shorter because she gave away 8 sweets. Sorry. So can you see that this difference here is going to be Okay, if I were to draw it down, this is going to be 8. Okay, and Belinda, right, has 5 times as many sweets as Wan Li. So Belinda did not give away, or Belinda did not receive any sweets, right? So the number of sweets that Belinda has, it has to be the same as before. And this will be how many units? 5 units. So if this Wan Li is 1 unit, but Belinda will be 1, 2, 3, 4, 5. 5 units. Okay? So guys, now, if we look at this, right, can we just make them the same unit size? Okay, so how do we make them the same unit size? This before model, right, 1 unit is actually bigger than the after unit. Okay, by how many? By 8. So I can actually cut this big model into 1 unit plus 8. 1 unit plus 8. 1 unit plus 8. Okay, so guys, can you see it? So now, can you see that this Belinda before and Belinda after is the same? So this Belinda before has 3 units. 3 units followed by 8 times 3, which is 24. Whereas for Belinda after, right, although it's the same number, it is actually 5 units. So guys, can we see this 5 unit as like 3 units plus 2 units? Okay, so this 1, 2, 3 units will correspond 1, 2, 3 will correspond to 1, 2, 3 units. Then you look at before, right, there's still 8 times 3, right? So this 8 times 3, it will be the same as these 2 remaining units here. So what we can see here is that 2 units will give us 8 times 3. That will be 24. So 1 unit, I will have 24 divided by 2, 12. Okay, so how many sweets did Belinda have? Belinda has altogether 1, 2, 3, 4, 5 sweets, 5 units of sweets. So to solve the problem, right, I need to find 5 units. So that will be 5 times 12, 60 is the answer. Okay, question 44. Mrs. Rani baked some muffins. She sold 3/8 of the muffins in the morning and 1/4 of them in the afternoon. She had 15 muffins left. Okay guys, for this question, right, okay, can you see that it's fraction of the muffin and it's 1/4 of them, and this then refers to the muffin. So we are talking about fraction. Can you please take note? Fraction of the same object. What is the object? It's the total muffins, right? So when we do such question, right, okay, what we need to do is to convert the denominator to the same number. Okay, so I repeat myself again, guys. This is a very common question. When you have fraction of the same object, okay, you see 3/8 of the muffins, 1/4 of them, it refers to the same thing. So when you have fraction of the same object, we will convert or change the denominator to the same number, right? So this 3/8, right, and I have 1/4. So 8 and 4, I can change them to 8. So 8 I don't touch, I just times 2 to the 4. So that would be 2/8. Okay guys, let me try to make sense out of this fraction to you. The denominator tells you the total number of units. Okay, so I'm going to convert the fractions to units. So all in all, I will have how many units? Look at the denominator. It's going to give us the total units. So I'm going to divide this into 8 units. Okay, and guys, this 3 over 8, right, is in the morning. So what does it tell you? It tells you that in the morning she sold 3 units. Okay, so I can just count 3 units. 1, 2, 3. So this is what she sold in the morning. And she sold 1 over 4, or 1/4 of them in the afternoon, right? So in the afternoon, don't take 1 because we have to change it to the same denominator first. So she actually sold 2 in the morning, 2 out of a total of 8. So that means we'll take another 2 and list it as afternoon. Is that okay? So that means she has how many units left? 1, 2, and 3. So this would be what is left. Guys, what is left, right? If you look here, can you see that it is 15? Okay, so this what is left, it will be 15. So 3 units gives you 15. So 1 unit will give you 15 divided by 3. That will give you 5. Okay, so how many muffins did she bake in total? We need to find 8. So 8 muffins will be 8 times 5. That will be 40. Okay guys, I actually skipped A. I found the B answer first. Never mind, let's go back to A. So what fraction of the muffin has she left? Guys, can you see that she's left with 3 units? Okay, she is left with 1, 2, 3. 3 units out of how many? 8. So the A answer, right, what fraction does she have left is 3 over 8. That's it.